So let's look at some examples of how we could rewrite some addition statements to write them in a different order. So here, if I have $5 plus 3 bananas, that's the same as if I just flip the order. I'm just going to write B for bananas. 3 bananas plus $5. Okay, and then here, 5 plus 3b, that's the same as 3b plus 5. Those two things are equivalent. Remember, this equal sign, there's a lot of meaning to that. It means these two things are equivalent. $5 plus $3, well, clearly that, if you added those together, that'd be $8. But if we rewrote the order of them, that would be $3 plus $5. And you could see in both cases this would be 8, so that is why that's true. Okay, here 5 plus 3, that's the same as 3 plus 5. And I think you can see the trend. So what I want you to do here is I actually want you to pause the video, take a few minutes, and go ahead and do all the rest of these on your own. Finish this slide out that you can see on the screen. And then when you are done, you can press play and we will go through these answers here. So take a second, pause the video, and do these next 5 right here. Okay, so hopefully you've given yourself a second to work on these. Let's do them really quick. Once again, I'm just going to write B for bananas. 5 bananas plus 3 bananas, that's the same as 3 bananas plus 5 bananas if I wrote them in the opposite order. And here we go, 5b plus 3b, that's the same as 3b plus 5b, because the order doesn't matter. You also might say that's 8b, that's true as well. 5 apples plus 3 bananas, that's the same as 3 bananas plus 5 apples. And 5a plus 3b, that's the same as 3b plus 5a. Okay, so here's why you did all these. The point of this is just to show you that when it comes to addition, I can rewrite these things in any order that I would like, and the answer will still be the same. That it doesn't matter if I add in any particular order. Even here, with this example right here, I can rearrange this in any order that I would like, and it'll be mathematically equivalent. So what if I put 2y first? Great. What if then I put the 9? Great. And so we've taken care of that and that. Then I need to add still 3y, and then 4, and then 8x. Right? So the order doesn't matter in which I add any of these things. I can add them in any order that I want, and my answer will still be the same. Now we're going to go through and we're going to look at some multiplication. 2.5 means 2 in words times 5, which you know is 10, and we could also write it as 5 times 2. I'm going to draw a little arrow. We could also write it as 5 times 2, and that little dot is just a notation for multiplication. It's another notation, right? So we can write times like the little dot. We could write 5 times like this. We also could just put 5 and then in parentheses put 2, and there's a, I didn't write that very well, so I'm going to rewrite that. We could put 5 and then in parentheses put 2. Man, my mouse does not want to cooperate. Let's see here if I can get it this time. Good, in parentheses point. That means 5 times 2. And so I can flip the order of this because order doesn't matter in multiplication, and in any case it will always be 10. Okay, what does 2.5b means? That means 2 times 5b. So this would be, another way to write this would be 5b times 2. Those two things are equivalent. And in either case, what I'm doing is I'm multiplying these two numbers together. Multiplication really is repeated addition. So I'm really adding 5b 2 times. That's what multiplication means. I add when it's 2 times 5b, that's the same as adding 5b twice. And so 5b plus 5b, or 2 times 5b, is going to be 10b. These parentheses right here, when I see something in parentheses, that, like we said up here, that implies multiplication. There's a hidden multiplication symbol right there between the 3 and the parenthesis. So if I'm multiplying 3 times 4x, that's the same as 3 times 4x, like that. And when remember, multiplication is repeated addition. So I'm adding 4x 3 times, which would be 4x plus 4x plus 4x. Obviously, 3 times 4 is 12, so this would become 12x. And then here, okay, this is where it gets tricky. There are 2 parts to this. There are the number parts, or the coefficients, and there are the variables. And basically what we do is we combine it all together. So I'm going to rewrite this. And remember, order does not matter, so I can rewrite this in any order that I want to. So what if I wrote all of the numbers first? So what if instead I wrote 3 times 4 times 5, and then so I've got the 3, the 4, and the 5, so I still need to multiply A times B times C. That would be like if I came back here to this example. 3 times 4x really means 3 times 4 times x, just like that, right? And that's where we get our 12x from. This is all multiplication, and I can rearrange it in any order. That's where that 12x comes from. Just like here, we're really multiplying each of these things together. When you write 3a, what you're really writing is 3 times a. So this is really 3 times A times 4 times B times 5 times C. This is all really one big multiplication problem. So we can rewrite this like 3 times 4 times 5 times A times B times C. And so now I multiply all of the numbers together. 3 times 4 is 12. And then this 5 is still here, so that's 12 times 5. 12 times 5 is 60. And then I can't combine these in any way, so this is just times A times B times C. So when I multiply this out right here, I can rewrite it individually like this, and when I multiply everything together, I get 60A, B, and C. So we're going to do plenty of practice problems where you will be working on this. And the important thing to remember is that anytime you see a number and a variable, just like this, 5x, let's say 5x, that really, there's a hidden multiplication in there. That really is the same thing as 5 times x. Okay? So you can go ahead and pause this video, and you can watch the next video to complete your notes for today.